the language, and access the settings and performance. We've now explored the features of the Connect, Open and Discover panes on the Tableau desktop start page. The data source page is one of the most fundamental but important parts of Tableau. After you connect to your data source, you'll be taken to the data source page. This allows you to make preliminary changes before starting analysis. You can also access the data source page at any time to update your data source, even during analysis. The data source page is primarily used as a way to preview your data before analysis. Here you can configure, clean and prepare data before working on it in Tableau. Generally speaking, the data source page consists of 4 main sections: the left pane, canvas, data grid and metadata grid. The left pane gives you information about the data that Tableau is connected to. Because we are connected to an Excel file, we can see the file name and type here beneath Connections. Just below, we can see the sheets contained within our Excel file, which behave the same as tables in a database. From Data on the menu bar, we can see options to add a new source, refresh the data source, and close the data source if it's no longer required. We can add a new connection to perform cross-database joins if we select Add to the right of Connections. We won't go into detail on this right now though. Let's look at how we can use the canvas to control our data source. We'll click and drag Sheet 1 from the left pane to the canvas to populate it. The data you choose to place on the canvas is the data that will appear in Tableau for analysis. After we added this sheet, you may have noticed new features appearing in the interface. Most obviously, our columns and rows of data from Sheet 1 are now being previewed in the below data grid. From the top of the canvas, we also now have the option to specify the connection type, live or extract. You can also add filters to the data at this stage from the top right of the canvas. Once placed in the canvas, you can ensure you have the most up-to-date data by refreshing your data. To do so, just select the arrows icon at the top of the left pane. Let's take a closer look at the data in the data grid. The data grid allows you to preview and review your data by displaying the first 1,000 rows before you begin analysis. The field names appear along the top of the grid as columns, while the values appear below. Our data looks fine, but we should clean some things up a bit. We can rename a field by double-clicking the field name and typing the new name. Let's remove the underscore from this title. Press Enter when you've finished making changes. Note that Tableau can automatically interpret and rename field names in certain cases. For example, Tableau may insert a space between 2 words where necessary. If we select the arrow above a field name, we can see further options. Let's hide this field, as we won't need it in analysis. Note that hiding a field here will mean it won't appear in the worksheet later for analysis. Tableau will also interpret the values of a field and try to determine the type of data it is. There are 6 data types Tableau recognizes: number, whole or decimal, date and time, date, string, boolean, and a variety of geographic roles. The type is indicated by the icon above the field name. Here we can see that Tableau has incorrectly recognized our date field as a string. To change the data type of a field, just click the icon and select the correct data type. This is a very important step, as your options for analysis vary depending on the data type. Also note the values of a field can be sorted in ascending or descending order by selecting the sort icon beside a field name. The fields themselves can be sorted with the above drop-down menu. To get a clearer overview of the data as a whole, you can switch to the metadata view by selecting the Manage Metadata icon above the data preview. Here, the fields will be displayed as rows along with the table they belong to. Once you're happy with your data and you've finished previewing, you can jump into the worksheet to begin analysis. Just select the worksheet name from the bottom bar. This is where you perform analysis and create vizzes. Though we won't go into detail right now, note our fields now appear here on the left. From the same bottom bar, we can create new worksheets, dashboards, and stories. If at any point during your analysis you need to return to the data source page, you can do so by selecting the Data Source tab at the bottom left of the window. We've now seen the basics of the data source page in Tableau. When connecting to data in Tableau Desktop, there are two connection types, live and extract. We will be looking at live connections in this video, which queries the underlying data source. Changes made to the data source would appear in Tableau in real time. To demonstrate this, we will be connecting to a Microsoft SQL server, but the principles apply to whatever data source you're using. So, to begin, let's look at connecting to our Microsoft SQL server. As you can see, we have SQL Server Management Studio open. We can also see the server type, name, and authentication here. If this is your first time connecting to a SQL server with Tableau, you may want to copy the server name by right-clicking and selecting Copy. And note the authentication, as these will be needed in Tableau. Let's select Connect and view our available databases. From the Object Explorer pane on the left, let's expand Databases. Here we can see our SQL Server has databases attached. For this demonstration, we will be connecting to the Wide World Importers database. Now that we've established our SQL Server, let's connect with it in Tableau. I'll open my Tableau window via the taskbar. On the left pane beneath To a Server, select Microsoft SQL Server. We need to configure some things before we can connect. We firstly need to enter the server name. Because I've already connected to this server, Tableau has remembered the name and placed it in the field. If, however, this is your first time connecting, you can paste the name we copied earlier by right-clicking and selecting Paste. If you want to connect to a contained database, you can enter the database name in the database field. We leave ours blank though. Next, we need the information to sign into the database. We have options to use Windows Authentication or a specific username and password. We leave ours set to Windows Authentication, as that's how we configure the server. You should check Require SSL if you're connecting to an SSL server, and check Read Uncommitted Data if you want to set the database isolation level to Read Uncommitted. You can also choose to run an initial SQL statement to be executed at connect time. Select Sign In to connect to your Microsoft SQL Server. As you can see, we have successfully connected to our database and have been brought to the data source page. When connecting to relational-based data in Tableau, a drop-down menu of available databases will be available on the left pane. Let's select our Wide World Importers database. Once selected, a list of available tables will appear in the left pane. Let's drag our Purchase Orders table to the canvas. And select Automatically Update in the data grid. Now that we've connected to our database, let's examine using live mode in Tableau. So, as alluded to in the introduction, a live connection relies on the database for any queries and provides real-time updates. Users won't have to extract data into the Tableau data engine. Note though that certain databases may not be optimized for fast performance. As a result, using live mode may make Tableau run slowly. To help visualize this, let's make some changes to our purchase orders table in the database. We'll update some values in the supplier ID field. Let's return to Microsoft SQL Server Management Studio via the taskbar. And from the Object Explorer pane, expand the Tables folder. Locate the Purchase Orders table. Right-click it and select Edit Top 200 Rows. Let's update some of the supplier ID values. and return to Tableau via the taskbar. We just need to refresh our data source by selecting the arrows icon at the top of the left pane. As you can see, the changes we made in the database now appear in Tableau. Though we use a SQL Server to demonstrate live mode, real-time updates are available regardless of the data source you use. As a general rule, if you need to make decisions based on real-time data, you should use a live connection. We've now seen how to connect to a Microsoft SQL Server, as well as the functionality of live mode in Tableau. The extract mode in Tableau Desktop is a way of bringing data into the Tableau data engine. It can help improve performance when working with the data and reduce the workload on the data source itself. It can also help you to prepare and filter the data before starting to work on it, and even allows you to perform offline analysis in Tableau Desktop. So as you can see, we're on the data source page, and we've already connected the tables from our Microsoft SQL Server. To extract your data, first select the Extract Radio button from the top of the canvas. Tableau will inform you whether this extract will include all data or not. Because we are extracting data into Tableau Data Engine, this can improve performance when analyzing data. Before performing the extract, we can instruct Tableau how to store, filter, and limit our data by selecting Edit. You can choose to store data in the extract as a single table or multiple tables, depending on what you need. You should use single tables if you need to use extract filters or aggregation. You should use multiple tables to help improve performance and reduce the size of your extract. Note that this won't allow you to specify how much data you want to extract. Note that these options only affect how the data in your extract is stored. How they're displayed in the data source page won't be affected. Next, we can choose how much data to extract by applying filters or aggregating data. The following features are especially relevant if you're working with a large extract. To add a filter, first select the below Add button. Select the field you want to filter, and click OK. This will open the Filter dialog box where you can choose to include or exclude selected data in the extract, but we'll select Cancel for now though. We can choose to aggregate data for visible dimensions. This aggregates measures using their default aggregation and consolidates rows, which can limit extract size and improve performance. If your extract has date fields, you can also choose to roll up dates to a specific level. If we were to aggregate data and roll up to the month level, measures that share dimensions would be aggregated into single rows and values would appear at the month level, greatly decreasing the size of our extract. Let's uncheck these though. You can also choose the number of rows to extract. You can extract all, the top n, or sample. Extracting all rows gives you the option to perform incremental refreshes, which when refreshed will look for new rows since last refresh and won't refresh the entire extract. You can then specify which column to identify rows with. You can extract a top number or percentage of rows, or a sample number or percentage of rows. Let's extract all rows then. Let's set it close and click OK at the bottom right of the Extract Data dialog box to finish configuring the extract. We can now save our extract by selecting the sheet name from the bottom bar. This opens the File Explorer where you can choose where to save your extract. Note the file type, .hyper. Hyperfiles allow you to create larger extracts with faster performance. Let's call this Purchase Orders Extract and save it to our data sources within the Tableau repository. From the Data tab on the left pane, note the symbol beside our connection indicating that this is an extract. If we right-click this and hover over Extract, we can see options such as Refresh. Note that the entire contents of the extract will be replaced during the extract refresh. Click Yes to continue. It's important to perform refreshes when available to ensure you get the most up-to-date data. Though we've saved our Hyper file, it's a good idea to save the workbook itself so that connection to the extract is preserved. We can do so if we go to File and select Save. If you don't do this, the workbook will connect to the original data source the next time it's open. Tableau also allows you to view the extract history. Return to the data source page and select Edit at the top of the canvas to open the dialog box. To view extract history, select History at the bottom left of the dialog box. This allows you to view when an extract was created, which action was taken, i.e. a refresh or incremental refresh, the number of rows extracted, and the source. Let's close these windows. We've now seen how you can extract your data in Tableau. SQL queries can be used to prepare or configure your data before analysis. They can also be used to get around certain database restrictions, append and aggregate data, and reduce data sizes. We'll add a custom SQL query and use it to create a basic unioning query in this video. So as you can see, we're on the data source page and we've connected to a multi-table Microsoft Access file. There are many ways you can use a custom SQL query, such as changing data types when joining, reducing the size of your data, aggregating your data, and more. Understanding SQL syntax and knowing the exact information you need is the key. For this demonstration, we'll be unioning data from multiple tables. We want to union the April and May tables. Let's drag April from the left pane to the canvas. But if we try to create a union with the May table, we can see we don't have the option. This is where custom SQL queries come in handy. We can create a new custom SQL by clicking and dragging it to the canvas from the left pane, or by double-clicking. We then need to enter the query into the text box. This will negotiate with the database and create a union between our April and May tables. Before closing the text box, we can preview results to check if the query is functioning as expected. And as you can see, our SQL query has successfully unioned our April and May tables. Let's close this window and return to the text box. We can also use parameters in SQL queries to replace constants in data with dynamic values or variables. Parameters can then be used in the workbook to update the connection. These can be handy if you're working with changing data. You can name your parameter, choose the data type and display format, and set the allowable values. We won't add one now though, so I'll select Cancel. To run the SQL query, select OK from the bottom right of the text box. If you perform a query successfully, it will appear in the canvas. The associated data will appear in the below data grid. And if we scroll down, we can see rows from both April and May. When you create a SQL query, Tableau gives it a default name, Custom SQL Query. We can change this by double-clicking the name on the canvas and typing a new name. Once run, you can then begin analyzing your data in the worksheet. If at any point you need to edit your SQL query, you can do so from the data source page. Select the arrow beside your custom SQL query on the canvas to view options, and select Edit to reopen the text box. From the same drop-down menu on the canvas, we can create a duplicate. This can be helpful if you need to rework the custom query and use it in the same workbook. To delete a custom SQL query, just select Remove from the drop-down menu. This has been a basic introduction to extracting data with a custom SQL query in Tableau. If you're running Google Analytics on a website or property, you can pull data and place it in Tableau for analysis. We'll see how to retrieve web data from your Google Analytics account, extract it into the Tableau data engine, and also how to connect other types of web data. Before we begin, we should draw attention to the Web Data Connector, which will allow you to connect to web data sources and explore them like any other data sources. Tableau can connect to most web data sources such as XML, JSON, and HTML. Beneath To a Server, select More. Then find and select Web Data Connector. In the dialog box, insert your Web Data Connector URL to the field, enter any information you're prompted for, and submit the page. The connector will then retrieve your data and import it to Tableau as an extract. You can use a connector made by someone else or create your own one. However, we'll close this dialog box and look at connecting to Google Analytics. Before connecting, be sure to have your Google Analytics account and password ready, as you will be prompted for them. Beneath To a Server, find and select Google Analytics. This will open a browser window, where you will be prompted to sign in with Google. You will need to enter your credentials if this is your first time connecting to Google Analytics with Tableau. However, we just need to select the account. You will then need to give Tableau access to view your Google Analytics data. Select Allow to proceed. Once authorized, you can close the browser window. Like with any data source, upon connecting, you will be brought to the data source page, though the interface appears differently. Let's take a closer look at the interface. Note that Tableau only supports extracts when connecting to Google Analytics. Live mode is unavailable. Tableau will create a default name for the data source at the top of the page. This can be changed by clicking it and then typing. Note the connected account is displayed beneath the source name. To perform the extraction, we must make 3 steps. Choose an account, property, and view, select filters, and select our dimensions and measures. In step 1, we are defining the source properties. We need to select the account, property, and view. Naturally, these will vary for you. Next, we need to define source filters. For date range, we can choose one of the preset ranges, such as the last 30 days, or select a specific range. Note that Google Analytics can only provide complete data up to the previous full day. We can also choose to filter our data by segment. Built-in filters are predefined filters, such as mobile traffic, that you can set for a Google Analytics connection. Whereas custom segments are defined by the user on the Google Analytics website. Filtering by segment can also help prevent sampling. The final step is defining the dimensions and measures to be used for analysis. We can add dimensions from the drop-down menu. Note that date has already automatically been added. For measures, we can select a predefined set of measures and add measures from below. Let's add bounces using the search bar. You can add up to 7 dimensions and 10 measures, but note that certain combinations can't be queried together. As stated earlier, we must perform an extract when connecting to Google Analytics. To do so, just select Sheet 1 from the bottom bar. This will pull the data into Tableau's data engine to allow for analysis. The extract files will automatically be saved within data sources in your Tableau repository. You can view this from the File Explorer. Within Documents, just open My Tableau repository, and then Data Sources, where we can see our different extracts. Let's return to Tableau. Note that Google Analytics may restrict the amount of data being returned if you try to retrieve more data than is permitted in a single query. In this case, sampled data will be returned instead. Tableau gets around this by creating multiple queries and combining them. In these cases, Tableau will show a sampling versus all data message, allowing you to decide how data is returned. If the query is unrestricted, like in our case, no message is shown. After the extract has been performed, you can begin analysis on your data in the worksheet. We can still edit our data source settings after the extraction. Let's return to the data source page. Beneath the Extract Radio button, we can see the exact date and time our last extract was performed. We can still edit the data source settings too. For example, we can add or remove dimensions and measures. But note that you will need to return to the datasheet to update the extract once again. To close the data source, open Data from the menu bar at the top of the window and select Close Data Source. Note that this will affect any worksheets using the data. We've now seen how we can connect to Google Analytics web data with Tableau. OData is a widely used open protocol for querying and consuming data. If you have access to an OData source, you can quickly connect it in Tableau Desktop and configure it for extraction into the Tableau data engine. So before we get into the demonstration, we should take the time to explain what OData is and how we'll be accessing OData sources in this video. OData, or Open Data Protocol, is an open protocol which allows users to create and consume queryable RESTful APIs in a standardized way. In plainer English, it essentially allows users a single way to access various data sources. Before we connect to our data in Tableau, we need to find the server URL for the data we want to connect to. For this demonstration, we will be using Pragmatica to visualize and explore OData services and generate said URL. In Pragmatica, we must first choose an access option, which in our case is metadata URL. I have already copied the metadata URL from the Chicago data portal, which I will paste in the empty field. With this pasted, then select Get Details and switch to Data Explorer below. From the Data Explorer, we can open the drop-down menu and select a data source. We'll be using libraries, locations, hours, and contact information, and pulling the top 1,000 rows. Pragmatica has generated the server URL, meaning we can now copy it and return to Tableau. From the Tableau Start page, under To a Server on the left pane, select More to view a full list of options. From here, select OData. This will open the OData connection dialog box. We need to paste the server name into the server field by right-clicking and selecting Paste. If authentication is required, you will need to enter the username and password at this stage. If not though, you can select No Authentication. Select Sign In to connect to the data source. The data source page gives us information about our data connection. In the top pane, we can see the data source name and OData server URL. We can change the name by clicking the field and typing. Let's change it so it's easier for others to interpret our source. If we select the Below OData link, the OData connection dialog box opens. You can preview the list of fields from the Below data grid. Note that these can be sorted with the above drop-down menu. Note that connecting to an OData source requires an extract in Tableau. The data will be pulled into Tableau's data engine for analysis. To perform the extract, select Sheet 1 from the bottom bar. The extract files will automatically be saved within data sources in your Tableau repository. Once complete, you can then begin analysis of your data in Tableau. This has been a basic overview of using OData in Tableau. Understanding joins is essential if you want to know how to combine data. By creating joins, you can work with related data values stored across multiple tables. So the goal of this video is to help you understand joins on a conceptual level. We will be joining two tables from this Excel workbook: customers and products. In Tableau, the data you use is often composed of multiple tables related by certain fields or columns. We can use joins to combine the related data on said fields. Naturally, your data will most likely contain more rows, but using smaller tables helps with visualization in our case. Our customers table has 4 columns: order ID, first name, last name, and order date. Our products table also has 4: order ID, price, discount, and product name. In this case, the related field is order ID. Note that fields must have the same data type to perform a join. For example, you can't create a join between numeric and string fields. Let's open Tableau via the taskbar and look at performing joins. We have already connected to our data source and can see both tables on the left pane. Let's drag customers to the canvas and note the appearance of the data in the data grid. We have our 3 rows and 4 fields. To create a join, just drag the second table to the canvas. As indicated by the Venn diagram on the canvas, Tableau has automatically joined our 2 tables. Clicking this will open the join settings. Tableau has performed an inner join and recognized the shared column name, order ID, so the clause is based on this field. These can be changed from here, but for now let's look at what's happening in the data itself. We now have 8 fields from both tables, but only 2 rows. It helps to think of joins in horizontal terms, like you're stitching them together side by side. The rows that remain depend on the join type and clause. Across our 2 tables, Tableau has only taken the rows that share the same values from order ID, 176A and 182B. To help visualize this, I have placed both tables in an Excel worksheet. The rows in green both share the same order ID. There is a disparity between the unhighlighted rows' order ID, so they aren't included in the inner join. Note that the type of join you use will have an impact on data implementation. Let's open the Join Settings dialog box by clicking the Venn diagram and look at the different join types. There are 4 join types in Tableau: inner, left, right, and full outer. As seen already, inner joins include only values with matches in both tables. As a result, they never produce null values. Left joins include all values from the left table and all matches from the right table. That's why order 150C appears in the data grid, even though it has no corresponding match, and why the right table has a row of nulls. The inverse happens with right joins. The left table produces nulls for values without matches, while the right table includes all matches. Full outer joins include all values from both tables, and members without matches show up as nulls. Because of the different join types, you should pay attention to the order you place your tables on the canvas in. Below the join types, we can configure the join clause. Tableau recognized the shared column name in our case, but you can edit this from the drop-down menu. The join operator can be changed from the middle drop-down menu, and you can even add new join clauses to create multiple joins between selected tables. To remove a clause, just click the X icon to the right of the clause. We can close the dialog box by clicking the top X icon. This has been a basic overview of understanding joins in Tableau. Once you understand basic joins, you can start to explore connecting data across multiple sources, known as cross-database joins. You can adjust and edit your join settings and even create calculated joins to ensure that the relationships in your Tableau workbooks are set up to get the most out of your data. When connecting to multiple data sources, it's important to know your data well. We have 4 data sources: 2 tables within orders V15, which is an access file, and purchase values and fulfillment centers, which are single table Excel files. Let's open these via the taskbar to see what kind of connections to make in Tableau. We want to join April and customers by the fields Customer Reference and Customer ID. We also want to join April and purchase values by item ID. And we want to join customers and fulfillment centers by name. Though this may seem complicated, the process is made simple and easy with Tableau. Let's just minimize these and open Tableau via the taskbar. So as you can see, we have already connected to a data source, a Microsoft Access file named orders v15. And we've also already joined the April and customers tables with an inner join by customer reference and customer ID. But say you wanted to join tables from different data sources. To do so, we must first add extra connections. Beside connections on the left pane, select Add. From beneath to a file, select Microsoft Excel. Then locate your file and select Open. Because this is a single table, it has been automatically added to the canvas. However, something seems to be wrong. Tableau is trying to join these tables, but it doesn't know which field to join them by. We need to configure this manually by selecting the data source field and corresponding field from purchase values. From the data source list, note the two table headings, April and customers. Tableau is giving us the option to connect the fields from any of our tables. You can also search for specific fields using the search bar. Because I know my data, I know to select item ID from the April table. And the corresponding field from purchase value is ID. Note that extra connections will be color-coded to help distinguish between them. It's important to note the difference between adding a new data source and adding an additional data connection. Adding a new data source creates an entirely new data source connection, replacing the current data source. Adding a new connection will join external data to this data source and create a cross-database join. Let's add another connection. Select Add from the left pane once again, and select Excel. Locate your file, and click Open. Again, because we connected to a single table, it has automatically been added to the canvas, and subsequently joined with the customers table, but incorrectly by the country field. This is generating 550 rows, which is way too high considering our tables have less than 30 rows each. The join field is incorrect, and so duplicates are being created. This is why it's important to know your data well when using advanced joins. We know the link between these tables is actually in name, but first and last names are split into separate columns in customers. For this, we'll need to use a calculated join. Calculated joins can be useful when you need to create joins without modifying the source data. From the Join dialog box, open the Data Source field drop-down menu and select Create Join Calculation. Let's remove the country field from here. We need to tell Tableau to combine our first and last name fields. Begin typing the field name and Tableau will provide suggestions. Note it appears in yellow within square brackets, indicating that this is a field. We then need to account for the space between the first and last name, so we'll insert a plus sign, followed by a space within quotation marks, and another plus sign. Then we just need to insert the last name field. So we are asking Tableau to take the values from the first name, add a space, and then add the last name. From below, we know our calculation is valid, so we can select OK. Then, from the corresponding fulfillment field, we need to select Name. Note that this doesn't create a new combined field. Rather, in the joining process, Tableau is treating the values from first name and last name as one based on our earlier calculation. This has been an introduction to using advanced joins in Tableau.